The International Association for Near-Death Studies presents NDE Radio, a weekly exploration of near-death experiences and similar encounters with the other side. Now, here's your host, Lee Witting.
Welcome to NDE Radio, brought to you by IANDS, the International Association for Near-Death Studies. I'm your host, Lee Witting. Our guest today, Deno Kazanis, PhD, received his doctorate in biophysics at Pennsylvania State University and served as a Peace Corp volunteer in Nigeria and Kenya. In addition, he studied Tibetan Buddhism with teachers of different lineages, including Dr. Yeshi Donden, former physician to His Holiness, the Dalai Lama. He has studied as well with masters of lineages of Tao and with lineage teachers of an intense form of Taiwanese qigong. Dr. Kazanis is the author of a remarkable book, The Reintegration of Science and Spirituality, Subtle Bodies, Dark Matter, and the Science of Correspondence. This very readable book provides a basis in physics for mystical spiritual phenomena, and new discoveries from science regarding dark matter are used to explain unanswered questions on the nature of paranormal phenomena, non-local mind, the power of prayer, out-of-body experiences, near-death experiences, reincarnation, and a whole range of mystical phenomena. Dr. Kazanis also presents an inspiring perspective on the traditional teachings and practices mankind has utilized to experience these phenomena. Dr. Kazanis, welcome to NDE Radio.
Oh, thank you.
It's this will be an interesting discussion because your book hits on a lot of things that I've always wondered about. Deno, you're right that the quantum mechanics shows that we can see and touch things in this world because of the electric charge of particles. In fact, all our senses and experience of the physical world is of electrically charged particles. So particles without that charge are invisible to us and untouchable as well. Would that be the construct for the world of the spirit?
Well, that's a beginning. I always like to mention that a lot of people don't really understand how science operates, including some scientists, and how it develops. And I've never had a physics class or teacher who simply told me that everything we see and experience is due to basically one force, the electric charge. And that's because atoms, as we discovered through quantum mechanics, atoms are made up of charged particles. They have a positive nucleus with a negatively charged electron traveling about it. And our whole experience, everything that we normally see and share, is made up of atoms, and atoms are operated by electric charge, best described by quantum mechanics. So, the fact we can see things, hear things, touch things, smell things, feel things, all of that really is just due to one force, and that's the electromagnetic force due to charge. So that's a good place to start. So if objects don't have electric charge, they're actually invisible to us. So it's kind of interesting, but I remember back in maybe 45 years ago or so, when I was first started getting interested in mysticism, when I was reading mysticism, I was always kind of amazed by how deeply they understood certain things, but I always felt that their understanding of the physical world was really off because I had a strong background in physics. And you'd find them talking about these different planes of matter. And I thought, that's really kind of silly. I know about physics. So I thought, and they really, there's, no planes of matter, other forms of matter as such. We pretty much thought we knew everything in physics in the sense of matter. That was our domain. So at the time in the 1970s, nobody knew about dark matter. It wasn't our consciousness of physicists or anyone. And in fact, you could read all or watch all of Carl Sagan's episodes on Cosmos, and nowhere in there will he mention dark matter.
Wow.
Now, that's not true of Neil deGrasse Tyson, who comes along later. And so he does mention dark matter, because dark matter was actually discovered during the 1980s. And one person really involved in that, a cosmologist by the name of Vera Guth, actually, you could say, really developed the understanding of dark matter through the 1980s. And I wasn't in physics at the time, so I didn't know this was going on until 1993, when they actually had the first international conference on dark matter. And so some stories came out. I happened to come across a well-written article in the Smithsonian about dark matter. And because I happened to be involved in, having studied mysticism and such from an intellectual point of view mostly, by the time I finished reading that article, I began to realize, we live in a really different universe than what we thought. So what we're really looking at here are essentially I was quite convinced it was other types of matter, other types of atoms, just as the mystics had been talking about. And so this really fit right in. And actually that was back in 93. And I was quite convinced at that time that people would make this connection. And I waited a year and nobody did. I couldn't find any people suggesting there were other types of atoms in the universe. And this apparently has never occurred to physicists, that this is what dark matter is. And it really wouldn't have occurred to me, had I not been studying mysticism. So I began to realize what mystics meant by planes of matter was actually literally other periodic tables of matter. So the universe, we know the one periodic table that's made up of charged particles, or protons and neutrons in the nucleus and electrons going about it. But we know nothing about any other type of atom. It's never been suggested. Now, it's not like dark matter is just a small part of the universe. In fact, dark matter probably, if you look at just matter, makes up 85% of the universe. So it's the vast majority of matter that exists. And so it strikes me as strange that really scientists have tried hard to really dismiss it, because I think it would be overwhelming for them to discover anything as profound as what I'm suggesting. So maybe in order to get a better idea of that, I always like to kind of go back because people tend to feel that science develops in a very systematic, methodical way. A led to B understanding, and B led to C, and our understanding, and D. That's how it's taught. It's taught as a very linear, logical, way of progressing in the universe. And I do want to say, science is still our best tool right now for working in the physical universe. It's a very valuable tool. So I don't want people get the idea of putting it down. But if we go back 120 years, we discover, if you look at how people or physicists viewed the universe at that time, just to pick out a few things. For one thing, relative to atoms, they thought that atoms were solid pieces of matter. They weren't made up of any other particles, and they also always existed. There was no beginning for any of the atoms or any of the universe. And these few things and many other things were really never questioned. I mean, people weren't asking atoms made up of other particles. That was something that wasn't even on the table. The universe was regarded as steady state. There were always the same number of atoms in the universe. And the Milky Way was the entire universe at that point. So they weren't even aware of other galaxies, which is kind of amazing when you think about it. So,
Yes.
so the interesting thing there is Thomas Kuhn wrote a book maybe 40 years ago, 50 years, on the structure of scientific revolution. So he tries to point out how actually, science doesn't proceed in this very linear logical way, but actually has this very revolutionary state. So, around 120 years ago, we had a major revolution going on in physics. In fact, if you just look back 120 years ago, there were physicists discouraging people from going into physics because they couldn't see anything they really didn't understand. So they really thought physics, they had completed the picture of physics. It was over, it was done with. And that's always a telling story. And you can find that in every science, and something surprisingly comes along. Well, what comes along in physics at the beginning of the 20th century is you have Einstein for one. You have also people were really exploring unknowingly the atom. I mean, the structure of the atom was kind of accidentally discovered by one of Rutherford's students. They used to bombard a piece of gold foil with alpha particles, and then they would just detect the number of particles that went through the gold foil, and on this fluorescent screen that would show up. This had to be counted by eye, so they get a pattern. Well, and one day they decided, well, I guess we better see what happens if any of them bounce back. They weren't expecting any of them to bounce back, but they did. And this experiment is really kind of not well known, but it's one of the things that led to the discovery of the nucleus, because what Rutherford realized is if something like an alpha particle is bouncing back off of an atom, and only a few of them are here and there, it's scattered amount, then he was able to calculate and determine that the most of the mass of an atom was in a very small confined area. And eventually they were able to show that it was protons and neutrons, and that the electron was not sitting in the nucleus at all, but it was traveling around it. So somebody,
I'm curious if we in the 20th century discovered the structure of the world that we can see and touch, but how did they ever come up with a discovery of dark matter if it's invisible?
Okay, yeah, well, that's a good place to start and move ahead up to the 1980s. And basically, what they discovered, and by the way, just to extend that a little, I mean, we now know back then they were thinking there was like one Milky Way, and some observations were done by Hubbard, who maybe discovered a handful of galaxies. Now they suggest there's somewhere between 200 billion and maybe 2 trillion galaxies. That's quite a jump.
Yes.
They didn't know about nuclear forces back then until they discovered that there was a nucleus for the atom. All of these things were totally unexpected and not really being looked for. So some cosmologists in studying distant galaxies were discovering that the behavior of these galaxies, for one, were just not correct in terms of the visible mass that was present. So after really careful testing and observations, they realized that there has to be a lot of invisible mass in these distant galaxies, and in ours actually as well. And then when they measured that, it would really come out to be much more than the visible mass. So they realized that galaxies contained a lot of invisible matter, and there was a lot of interstellar matter because dark matter, actually, one of its properties is that, of course, it does have mass, and mass does bend light according to Einstein's general relativity, which is the one on gravity. So gravity actually bends light. So they were also by observing light traveling from distant galaxies and stars, they could tell that it was being bent. And so they would observe it from different points of the Earth. So they were able to determine there was an awful lot of invisible matter in this universe. And not everybody wanted to buy into that. Early on, some of the physicists were trying to explain all of that by changing Newton's equations, either his laws of gravity or his law of F equals ma. By modifying that, they could, to a certain extent, account for this phenomena they were seeing. But eventually, there's other more detailed work done, and so that at this point is pretty much gone by the wayside. So most people, most physicists, vast majority, agree that there's a lot of invisible matter in the universe. So, of course, my suggestion was that, which is a big leap, but nevertheless, I saw that having confidence in mystics and also understanding that these invisible planes of matter played a role in our universe for them. What I discovered was that what the mystics meant by the planes were actually entire periodic tables, is how I would interpret it now. I don't think they could have used that wording back then, but entire periodic tables of matter. So there literally could be dozens of them. Now, usually we break the subtle bodies up into, it depends what culture you're working with. In mystical Christianity, you usually have 7 subtle bodies, such as of course, the visible body. Then there's the etheric body, and the mental body, and various the soul, and those types of bodies. Whereas when you're talking about the Eastern mysticism, like of India, you basically have 5 subtle bodies, which is what I normally use because it's the simplest. China apparently has a system of 6 bodies, and go back to ancient Egypt, there are really a dozen subtle bodies. So they, like I say, seem to have been much more into it, aware of it. I think you'd have if you were aware of all this other subtle matter in the universe, you'd probably have a hard time coming up with Newton's laws, because Newton's laws seem to be really confined to mostly to the universe of charged matter. I think the physics gets a little more complicated when you start including all these other types of subtle matter that.
Well, at some point, the I guess perhaps you could call it the Enlightenment, science verged away from the mystical interpretations of the Middle Ages and alchemy and subtle bodies and so forth, and went off on its own and just had nothing but scorn for the other way of seeing things, even though they're just perhaps 2 different names for the same thing.
Yeah, so I think as we began to focus, strangely enough, I think Newton would have been surprised because he was so much into alchemy, but as we began to focus more into charged matter and became less aware of the subtle matter in the universe, then that seems to be the only direction that science has been going in for a long time now. So it's really time for that reintegration back into the matter plus subtle matter, and the metaphorical universe of the alchemical way of viewing the world, because those systems, the alchemy, really lead to the understanding and the wanting to explore chemicals and eventually the development of a periodic table. It's the same with astrology and astronomy. It was the utilization of astrology and wanting to be more and more accurate about the predictions that astrology would make that eventually led to astronomy. And as we seemingly limited ourselves more into the world of charged matter, we became less and less aware of the mystical. So it really is time to move back in that direction, and that's what I'm hoping I can help people do with this book.
Do you think that perhaps there was some pre-civilization or prehistoric knowledge of dark matter that would have implanted these ideas? I mean, how did people begin to think of subtle bodies and I mean, it's not something that you would normally think of in a three-dimensional world.
Right, but I think the mystics of all ages were really able to move their consciousness into a level where they could actually see these subtle bodies. I mean, they must have been able to be because they just had too much awareness, too much knowledge of it. The chakras and how they're arranged. They even talk today when they discuss those things, as you talk to mystics who have studied these things. They can tell you how many nadis or fibers there are in the subtle bodies and the chakras and where they are. And what they don't talk a lot about is the external world of dark matter that they might experience, and possibly because that's less important. But I do think if you were to read one of the people that does talk about it is Swedenborg in his books. Swedenborg for a long time published his explorations of heaven and hell and really other worlds under a pseudonym. And it was quite a while before people, although some people apparently were suspicious that it was him, but Swedenborg was an extremely well-known person, the type of person who the newspapers would tell you what he was doing, where he was going each day. So he was a really very well-known person. And then suddenly, for some reason, or somehow I should say, discovered the mystical nature of the universe and started exploring that. So he's influenced actually people like William Blake, who does mention. I talked about William Blake talking about how that the creation of matter was in stages. It was you had extremely subtle matter, less subtle matter, and more and more dense, until you eventually create charged matter, which is what the Big Bang is. Because if you look at the Big Bang, it really is the creation of what is necessary to create charged atoms. So that's, William Blake obviously had an understanding. I don't know how they could get so far. I always feel like even if you go back to the Bible where they say the universe is created in 7 days, well, they could really just be talking about basically 7, stages of creation. Stages being stages of matter, stages of atomic matter, really.
There's a scientist named Gerald Schroeder who wrote a book in which he equated the 6 days of creation with the way the time expanded from the moment of the Big Bang and the distortion of time, so that he was really looking at this from the point of view of if you were standing outside of the Big Bang, you could have 6 days go by, the equivalent of what would be 6 days for us. But for us, looking back through that expanded time, it looks like 14 billion years.
Yeah, that could be one way of looking at it, but I really feel, though, that dark matter existed before what we regard as the Big Bang. And I think there's a mistake that physicists, someday some physicist is going to realize that dark matter could have existed before the Big Bang, and they'll be able to solve some of the problems they have with modeling the Big Bang. Because one of the problems you have in modeling the Big Bang from a scientific point of view is that no matter what you do, you seem to be able, well, the Big Bang will create as much matter as antimatter. So when you look at the universe, though, after the Big Bang, there's not much antimatter, it's almost all matter. Well, if you're creating the universe out of a vacuum, you're going to be stuck with that problem. But if there was some matter with certain properties that existed before the Big Bang, I think that problem could be overcome. So that's one of the things that I really like to point out, and it's something that the physicists have not yet even considered, and I hope they do at some point, because I really think it will solve some of their modeling problems on the Big Bang. They always have dark matter showing up, very early after the Big Bang, but they can't think of it existing before.
Well, that's really interesting. Are you saying that there is antimatter encapsulated somehow by dark matter?
No, I just don't think that the amount that antimatter gets created in the universe, if you have a certain type of dark matter existing before the event that created matter, charged matter.
I think I read somewhere that when matter and antimatter were created, that there was a discrepancy in the amounts, and that what we have today in our world is the leftover from the annihilation that took place between the remaining matter and antimatter.
Yeah, they have tried to find a way to explain away the lack of antimatter, but I think ultimately the way that will be explained away is by putting dark matter before the creation of charged matter, so that very little, if any, antimatter is actually created at the event.
Would that be a separate Big Bang that would create your dark matter?
Well, what I'm saying is there's a series of Big Bangs. We probably started out with extremely, extremely subtle matter, and eventually made our way through a series of events. And this is what William Blake seems to suggest, that there are a series of atom-creating events, the last of which is charged matter. And it's the creation of charged matter is what we're calling the Big Bang. We can't see all the other events because we don't know how to see them, because none of it has to do with charged matter.
Deno, let's stop here because we're out of time for today. But let's go on with a show for next week as well. And in the meantime, tell our listeners how they can find a copy of your book.
Okay. The best way to find it really is through Amazon. And it's called The Reintegration of Science and Spirituality. And there's a paperback edition, and there's also a Kindle book, which is a little cheaper.
Okay. Well, my thanks again to Deno Kazanis for his work integrating physics and spirit. We're going to continue next week on NDE Radio, and we will probably get further into the study of consciousness and perhaps some more discussion of the near-death experience as it relates to dark matter and subtle bodies. So thanks again. If the listeners would like to hear this show again, just go to TalkZone and hit the past shows button for NDE Radio. And stay tuned next week, Monday, 11 a.m. Eastern, for more NDE Radio. This is Lee Witting saying thanks for listening.